Welcome everyone to RVA Tech's Tech It Yourself webinar series. Today we're joined by representatives from Impact Makers who will dive into how to accelerate analytics via Data Vault. We have David Moxley, Senior Consultant in Data Science, along with Brett Burnham, Lead Consultant in Architecture and Engineering. If you have any questions during the presentation, feel free to enter them in the Q&A box and we'll address them towards the end. With that, Brett and David, I'll let you all take it away.
Okay, thank you so much. David, go ahead and start sharing whenever you're ready. So welcome to the webinar on accelerating analytics via Data Vault. So given, yes, it's 2020 and COVID, you might hear a bird chirping, my dog barking, or a general interruption. So let's just go with it, however it works. Let's go ahead and start with introductions. Once again, I'm Brett Burnham, and with me is my esteemed colleague, David Moxley. He is our Senior Data Science Consultant. He also plays many roles as far as he's an incredible engineer as well as a visualization expert and all-around great guy. So it'll be a great presentation.
Awesome. Thanks, Brett. I'm excited to be here. Thank you, everybody, for attending. As a visualization expert, Brett, I think there's something different about you. Do you have different hair? Less hair, maybe? Is that what's going on?
I mean, let me get this straight, David. You're a data scientist. I'm giving you 2 points of data right here. On the left is me in December of 2019, and in the middle is me in 2020. And all you see is the lack of hair.
Causation does not equal correlation, and the plural of anecdotes is not data, my friends. So I don't see we get a larger sample size.
We'll go with that. Okay, so if you're just joining us, I'm Brett Burnham, Lead Consultant with Impact Makers, and with me is David Moxley, some guy that I work with. So let's go ahead and get started. And so at Impact Makers, we work with both commercial and public sector clients, specifically helping to address their data needs. So what we have seen and what we are seeing in the industry is that most of the time, the use case and the hypothesis are there. The business knows what they want. The real hang up is getting the data to the business and to the data scientists in a way that is accessible, integrated, trusted, and understood. So we are here today to describe a method that is faster and more reliable, an approach to delivering data to meet those business use cases and to make the data available for those people like David who are data scientists. So we do this by timely delivery of business value. That's the time to value. Solutions that are tailored to the client needs, incremental delivery of scalable, holistic solutions, and more specifically, in today's example, a single architecture solution for both self-service analytics as well as advanced analytics. So in order to demonstrate this, we're going to walk you through a composite client. It's fictitious, but it's really a culmination of a lot of our combined experiences with some of our financial services clients as well as our expertise.
So with that, our composite client we're going to discuss today is kind of taking on the role of a growing community bank. So a lot of momentum, a lot of desire for digital transformation, but they're not necessarily there. They've undergone a recent leadership change, which is part of the impetus for this digital transformation and desire to focus on analytics and ways to improve their current analytics and, of course, expand upon them. But also they're facing a more immediate challenge in the form of new regulatory requirements. So what this particularly means for us here is they're presenting us with 4 immediate pain points. They have this painfully manual financial reporting process of cumbersome spreadsheets that require interventions from multiple departments just to yield a balance sheet and income statement. The examiners, however, have come through and asked that this report be delivered to them on a monthly basis. So now you got to make sure you have continuity across your different departments in terms of a single source of truth for these important financial metrics. But also you have that request from senior leadership that they might be able to look at a more enhanced frequency. But none of this is possible without some sort of integrated data source to serve both these reporting needs as well as projections to deliver 5-year looks at various financial metrics. Data currently is not at all centralized from their core system, and they have multiple ancillary and secondary, tertiary rather, systems of data. And all this is going to have to operate under a compressed 12-week or so turnaround time. However, as we're delivering this to them and trying to get the solution out the door and user ready in 12 weeks, we want to make sure we're not saddling them with a boatload of technical debt, and also that we're acknowledging their larger digital transformation vision by addressing several key strategic objectives.
And so as David mentioned, it's not just tactical, it's also strategic. And so we have to look out for whatever is put in place can accommodate the long-term vision, the rapid growth, either a merger, acquisition. There also has to be room and accommodation for self-service. And it's not just about the reporting, but it's also about being able to accommodate the predictive as well as prescriptive analytics. And then there is a recognition and a need for governance, as well as something I call data transparency. It's the data has to be discoverable. It has to have the proper lineage. It has to be understandable and with common definitions.
So, as I mentioned at the outset, for the purposes of this presentation, I'll be looking more at the analytics role, but also kind of considering what the client voice would be. So we want to just take a second to really articulate what the business need is. At the moment, you have this Excel-only report system that's very limited both in functionality and, of course, cumbersome and time-consuming to develop. They don't, as a result, have the necessary patterns nor capacity to scale this to meet the regulatory requests or the frequency that the leadership would like to see. And they lack the data and capability for advanced analytics. So where they'd like to see us transition is to focus on 2 primary areas in business intelligence and advanced analytics. First is delivering a stable reporting solution for the balance sheet and income statement, and again, tracked on a weekly basis for senior leadership. And second, capacity to provide multi-year projections for the examiners that need to be substantiated and built off real data. Year-over-year averages in this instance will not suffice. But for anybody that's ever done this sort of work, you'll know intuitively that these 2 things typically require 2 very different sorts of data sources. So, of course, you have variables and granularity differences, differences in the length of history, as well as some requirements for business logic and some requirements for engineered features, that don't mesh across the 2 verticals there. With BI reports, typically you have a very well-defined use case with very specific variables, often derived based on some inherent business logic, at a set granularity and a defined portion of history. In contrast, in advanced analytics or machine learning, choose your poison there, it's a lot more exploratory in nature, where you want the greatest depth and breadth of data, the full data fidelity, in order to determine what and where the signal lives. So while variables may be partially defined by the underlying business theory, they're not exhaustively defined. And you would be obviously limited if you started with a star schema or some sort of business layer developed for BI reports and intended to build a model off of that. So with that in mind, we're able to then decide what methodology can address both of these problems for us on the data end.
Okay, and so we need to build a modern data ecosystem. And so I would encourage you to check back at the older RVA Tech Teach It Yourself series. Our colleagues, Tara Mason and John Pimlett, back in September, gave a webinar entitled Delivering Business Value with a Modern Data Ecosystem. And in some respects, this webinar is a continuation or a deeper dive from that. So there's definitely something to check out for more of a generalized view of this modern data ecosystem. So in order to do that, we need to choose a methodology. And so what we're going to do is we're going to walk through a couple different of the traditional methods for delivering these kinds of systems, and then we're going to choose one. So spoiler alert, if you saw the name of the presentation, we're probably going to choose a data vault, but let's see what happens. Okay. And so what we have here, we have the traditional methods. And this is not meant to be a comparison of Kimball versus Inman versus Data Vault. This is really going to be a condensed version of that whole comparison methodology. First, you had Bill Inman. You had the Corporate Information Factory. It was a big bang type of implementation. It was slow to value. Some of the details about it, it was a third normal form. It was flexible in the sense that you had all the atomic data in one place. You had one place to update, one place of reference for subsequent layers. And even Inman said you didn't necessarily have to have the consumption layer be in third normal form. That could be a Ralph Kimball. And so some of the disadvantages of that, besides the Big Bang, was this concept of the single source of truth. And this is really true in either Kimball or Inman, where you have this fallacy of you can model and you can build something that is right for everybody. And we're going to get more into this later, but it's something that we think is a fallacy. With Inman, also the ETL is more cumbersome as far as you have more layers. You need specialists to be able to do the data modeling. And it is, it's overall, I wouldn't necessarily out of fashion, but most of the data warehouses I've worked on in the past 20 years have been the Ralph Kimball method. And by Ralph Kimball, that's the one on the right over here. The advantages of that are really in the consumption. The star schema model is easily understood by business users. BI tools, for the most part, are geared towards a dimensional or a star schema model. The querying methods and patterns are more efficient than trying to get something out of a third normal form, for at least for reporting and analytical purposes. And it's smaller footprint, easier to maintain, less hops. But there are definitely disadvantages. If you've worked on a data warehouse in the past, you probably know it's not all roses. The data is not fully integrated beforehand. So if you miss something in your consumption layer, you really have to go back to the start, back to the source. The dimensional model is really cumbersome to adjust to change. If you ever had to reload a type 2 dimension or go from a type 1 to type 2, it is cumbersome. It's not insurmountable, but it's just one of those challenges with the Kimball dimensional modeling. It is process focused instead of not necessarily enterprise focused. And it does serve as a relatively poor system of historical record. In that sense, data in a dimensional model is only really as faithful to the history of the source system across dimensions to the extent that the dimensions are related to facts. I can't dive too deep into that right now, but needless to say, it's not a good place to have your archive data. And two of the biggest hangups with these two methods are really they rely heavily on the ETL or extract transformation load pattern to move data across. And so let's dive a little deeper into ETL in the next slide. And so this is the old school extract, stage, cleanse, transform, and then you load. And with this, it's really subject specific logic. It's not well suited for automation. For model changes, they can require developers to go back to the source for historical data. So if you screw something up on the end, you have to go back to the beginning. It really assumes transformation and cleansing requirements are acceptable enterprise-wide. You're kind of saying that the transformation that I'm going to do beforehand is what everybody wants to see and everyone knows what I'm doing. But in some sense, it's hard to untransform. This gets back to the single source of truth myth, where what you're trying to do is right for every line of business. We'll get more into that later. It also precludes any kind of architecture with a raw data store. You constantly, if you've ever heard a data scientist say, what did you do to the data? I just want the raw data, please. I'm sure David said that before. Also, for the traditional ETL, success depends on having all data quality and business needs known up front. and hope that they don't change frequently. Because with the traditional ETL, changes are difficult to apply, tables have to be reloaded, and also it leads to what I call ETL fiefdoms, where you don't really know what's going on. It's only the ETL developer who created the routines who really knows and understands what's going on between extraction and load. So with these traditional approaches, what we found is just throwing an agile product delivery method on top of to delivering a modern data ecosystem on top of the traditional approaches doesn't make it as agile analytics. This really goes a lot back to the traditional methods. You having to understand all the data in the source and know all the use cases up front before you can begin, and you really don't start getting business value until the end. Another thing, this goes back to the simple fact that you don't get things, it's hard to get things right the first time. And so the more iterative your approach, the more successful you're going to be. Enter Data Vault. Here we go. All right, so Data Vault at its simplest form, it's a data modeling technique. I prefer to refer to it as a framework or a methodology. It is business key focused. So it is focused on business key integration to the raw data vault. The raw data vault sits there in the middle. We're getting to that more in a bit. So what is a business key? A business key, it's a little hard to find, but it's any source system identifier. It's literally anything that the business accepts as a key. I'm thinking things like employee ID, account ID, customer ID. Now these eventually translate into, like I said, Data Vault is also a data modeling technique. So business keys eventually translate into something we call hubs, which is the type of table in the raw Data Vault. Now, Data Vault also tracks the full fidelity of the history of the source system changes. So you have full history of those tables or files that you have ingested. Now, this modeling technique of focusing on business key integration is really key as far as it helps avoid the pitfalls of the other traditional methods. And what I mean by that is really the hang up is with things like the relationships between keys. And so this is like in the Inman and the dimensional modeling, data modeling techniques, you're constantly having these arguments, especially with dimensional modeling. Okay, do we represent this as a one-to-many or as a one-to-one? And then even in the Inman model, you're constantly having to make a decision about, do you refactor later with a one-to-one, or just do you accommodate one-to-many in the beginning? And so the other key besides the business key is the business key relationships accommodating the many-to-many relationships. The Data Vault allows for the full audit trail from source to raw Data Vault. This is key in a highly regulated business like banking, finance. It leans heavily on the ELT, that's extract, load, transformation, data movement pattern. So what we try to do is we try to avoid early transformations. We push these soft business rules or these transformations to the right. If you're looking at from source left to consumption to the right. All right, and so raw Data Vault is all the history. There's no dependency on the single source of truth. What we have here is a single source of facts. And so you gotta think about, you have different lines of businesses, and different lines of businesses, at the end of the day, a lot of them, they wanna see the data in different ways. Now, things like MDM can help bring that in line to a certain extent, but at some point, marketing doesn't want to see customer the same way as finance, as risk. Lines of businesses has different perspectives. So if you have a single source of facts to go back to, you can always have these different perspectives, which is the different sources of truth. Now, with the raw Data Vault, ultimately, just one last thing on this, the raw Data Vault ultimately is not necessarily has business value in itself. It's really in those layers off to the right here. You see this information delivery. That's where we have our star schemas, where you still have a Ralph Kimball dimensional model. You have your report ready tables and report ready layers over there. And that's where the consumption usually takes place. All right, next slide.
So all of these features of the two different major buckets of methodology comparisons, your more traditional analytics and then this agile analytics approach, all are great. And ultimately in selecting, we need to identify which ones map back to our primary client needs. So, first and foremost, there's an immediate need for analytics. So through the agile analytics approach, we're not boiling the ocean. We're able to decide what's going to be consumed and focus on rapid delivery of those data elements, right? Build it and they will come. They won't always actually come. Second, we want to make sure that we're integrating multiple source systems. And so while either technique can obviously accommodate multiple source systems, the additive nature of Data Vault in particular meshes well with an agile team structure. So you can actually start parallelizing development as opposed to working more in a sequential, waterfall methodology, even if you're, quote unquote, agile in your Scrum teams. The third main piece here, of course, is your auditability. We're working in the financial sector, and as Brett mentioned, that's being able to offer to examiners, rather, this clear data lineage is paramount. And it's much more transparent in a Data Vault environment. When you have exact copies stored within your source environment, you can use these very clear patterns of development to recreate from the report the original source system, as opposed to a more traditional approach that tends to have much more complex structures and ETL patterns. And then lastly, looking at something that is scalable and extensible. A lot of these smaller companies, particularly with a large growth velocity, might be looking at mergers and acquisitions or being acquired themselves. So being able to iterate and to scale based on the business need, and also have a solution that is extensible for future needs is very important. And that additive design of Data Vault really does well without having to go through some of the more extensive code refactoring practices that take place with a centralized data warehouse. So those are the four sort of primary reasons why Data Vault for our composite client here is what we would want to go with. But how do we actually achieve this vision through agile analytics?
Okay, thanks, David. So Data Vault in itself is not an architecture, it's not an implementation. And so what we need here is a architecture. So this is our composite client's conceptual architecture. It's really the independent of the deployment or the physical implementation. And so I do, we're not going to go through this in depth. I do please refer you to Tara Mason and John Pelmet's discussion on delivering business value with a modern data ecosystem back in September. This is a flavor of that reference architecture that they went over there. I will make some notes as far as we do, let's see, there are things on here that are not part of the initial use case delivery for this composite client, such as this Dream Hub, the master data management. Those are things that are not part of the initial use cases, but they're on the reference architecture for that future capability. Also note, I talked about this earlier, data moves from left to right. I'm big on that as far as when I say pushing things right and sourcing things from the left. And we do have a data lake on here, but that is purely for purposes of a persistent staging area. And we'll get more into data lakes in a minute. Let's go ahead and next slide. And so here's how we're going to solve this problem for our client. So first of all, we start with explicit business intent. We're going to start with an explicit business need, and that is the balance sheet that they need at first. So we're only going to model and ingest the data that is necessary to fulfill that business capability. All right, and so what we do, we delivered a balance sheet based upon one source for the client. Now, this is just one source, but I don't know if we mentioned this, but in this case, the client didn't have the history tracking that in the source system that there was necessary to be able to complete the balance sheet. And so that's where in the raw data vault, we have the data to meet that business need. What do we do next, David? Okay, all right, so we have the ability to adapt to changing business needs without refactoring the raw data vault. So I'm thinking of 3 different scenarios here. One, we had a change in business requirements. What did we have to do? We didn't have to go back to the start. We have all the data in the raw data vault. All we had to do was make a change into our business consumption layer to be able to accommodate that change in business need or business requirement. Or perhaps we had a different line of business, want a different perspective on the balance sheet. Less likely, but in that perspective, we could have added another report collection and an additional balance sheet to be able to meet that need. Or what's more likely is we screwed up the balance sheet. We got it wrong and we failed. And this happens all the time. And with these type of implementations, it's hard, things go wrong, but with an incremental delivery of a data vault, we don't have to go back to the source. We don't have to go back to stage. All we have to do is make those corrections in the layers to the right where the error occurs. Because after all, we all fail. I can think of the first time that I gave my data vault presentation. It was definitely a crash and burn, and that happens.
What happened the second time?
The second time I gave the presentation, I don't know, but it's looking pretty good so far. So regardless of how we failed, we have to remember that we didn't have to change our extraction pipelines. We didn't have to refactor the raw data vault. We didn't have to do remodeling. Okay, I'm just looking at the chat window here from my boss from 20 years ago. Okay, and then let's go on to the next one. So what else did we do? We actually gave our client self-service, and not out of the report collection, but out of a dimensional model, a star schema. Now, we didn't have to source new data. We didn't have to add new data to the raw data vault. This is additional capability out of the same data set from the raw data vault in the manner of self-service. All right, and then what did we do? We got that predictive and analytic. There we go, look at that. Okay, the next thing we did, we actually ingested new sources. So this is where a data vault, well, any analytical environment really comes into accelerating its value. It's really in the integration of additional disparate source systems. So what we happened here, we added 2 more sources. We didn't have to change the raw data vault because it's additive. The data model is additive. So we added additional hubs, links, and satellites to the raw data vault for additional capabilities. And what we're doing here is we're doing our predictive and prescriptive modeling out of the raw data vault. David's going to touch on this later. But as you can see here, it's an incremental delivery. So the key takeaways, besides, it's the iterative nature of it, the repeatable patterns help expedite the development process, and it's adaptive. It's adaptive to the change in source systems as well as changes in the business. And it's also adaptive to the just not getting it right the first time. All right, so let's talk a little more about the modeling. This is where we try to go a little bit deeper into Data Vault and a little bit about the ELT versus ETL. Okay, so as we talked about, Data Vault is business key focused. And so the 2 goals are to be able to integrate the business keys in the raw data vault and to be able to recreate the source from the frequency in which you ingest it. And so what we do with our data vault implementations, if we can recreate the source on a daily basis, we've won. That means you have that full history, that full fidelity. Another thing we have here, so we have our 3 kinds of primary raw data vault tables, the hub, the link, and the satellite. The hub, as I talked about earlier, is really the business key. And so in this case, we go from, and so we'll see that in a subsequent slide. So the links are the relationships between the business keys, and the satellites are all the other attributes that are not the hub or the link. And so let's look at a specific example for this composite client. For one, let's just say this is a table called account. If that is one table in the source system, we're going to have one staging table. I'm going to load that to the raw data vault into 4 different tables. One is the hub account, another is the hub customer, And then those are the two business keys, the account ID and the customer ID. And then we have a link, which is the relationship between the account and the customer, accounting for the many-to-many relationship, should the need arise. Now, the satellite account is all the other attributes from that account table in the source system that are not either the hub account or the hub customer. So it's hub business key, link is a relationship between business keys, satellite is everything else. All right, moving on. So this is a little bit deeper. And what I want to highlight here is really the different layers, the source, stage, raw data vault. You have something called a business vault, an information mart, a business layer. All these layers aren't necessarily materialized. They're not necessarily all tables. Our methodology is we like to virtualize till it hurts. As far as the layers in the information mart and business layer, these are all tables, by the way. This is a modeling technique. As far as the business layer goes, that's where primarily the consumption of either for reporting, for the traditional analytics, file extracts, all of that comes out of the business layer. And this is also where we can represent those different perspectives to the business. And because that's virtualized, it's easy. Okay, marketing wants to see it one way. Finance wants to see it a different way. Okay, we give them two different views, literally different views of the same data. And this is also in the business layer on the right, where we focus on security, as far as if that's where people are accessing the data. You really lock down everything else, and then you look at your granular level security within the business layer. It's also where we focus on metadata. You can boil the ocean, you can have metadata for every data element in your ecosystem. Good luck, we'll see you in 2060. It's just not gonna happen. We spend the effort on metadata in the business layer. That's where it's consumed. That's where the metadata is most valuable. Okay, let's go on to the next slide. So automation and acceleration. And so as David mentioned, I've mentioned, Data Vault is ripe for parallelization as well as automation. There's really only a handful of different loading patterns and modeling techniques to the point where it's low-hanging fruit for automation. There are some things like the business layer or really the extraction where you really want to stay out of the game of automation. As far as there's no two source system is the same. You might be doing CDC on one source system, it might be a full extract on another. It's difficult to try to automate the extraction. The business layer, that's unique to your business. Some people play in that space. We don't. We really want to stick with the automation acceleration in between the data lake and into the raw data vault. Another place we play is in the data validation, as far as we talked about earlier about trying to recreate the source. What we found is along with automating the pipelines to load the raw data vault, we also can automate the validation of that data. And one thing I didn't mention earlier is in Data Vault, there's a different concept between data validation and data quality. Data quality is an assumption that is best left to the hands of business, not to the engineers. Whereas data validation, we're really looking at did what we loaded to the raw data vault was what we extracted from the source system. And data quality, we push that to the right as far as in subsequent layers in the business layers. That's where we really enforce data quality measures based upon business input, not from what Brett thinks the data should look like. And as far as acceleration, we've gone from automation and Impact Makers to acceleration. At this point, we do code generation. We have a tool we call Rapid Vault, which we use to accelerate Data Vault implementations.
So with that, Brett has built a beautiful Data Vault now that I can leverage for analysis, exploratory analysis, report development, and model development. Similar in the same way that the Data Vault doesn't have to be completely built. We don't need to wait for some sort of monolith data warehouse before we can begin the analytics process. We can kind of work in concert and continuing that sort of agile development patterns. So once we have some data to work with, how do we deliver for the business using the Data Vault? So returning for a second back to this architectural structure here that Brett walked us through of our client, I think you could probably start to see exactly how we would do it. In fact, I would say that it's fairly self-evident that you start with the business layer, right? And that can be structured in a way that's very familiar both for BI tools and BI report developers, and use those Kimball star schema-like structures that those tools are designed to use and consume. So from that rapid development there, that also frees up a lot more time for data analysis, exploratory analysis, and data science activities. So how explicitly would we do that with Data Vault? So I think it's kind of important to pause for a second and maybe consider some of the other alternatives that are out there. So most popular one really is working with a data lake, right? And so conceptually what's happening here is you're taking all of your various operational systems and dumping them into a data lake, right? You have, if done correctly, an unadulterated full data fidelity, exact copies from your source system that you can have all the history and granularity that they provide in the original data formats. It is, again, if done correctly with correct MDM, very navigable, right? Querying for the specific fields that you like from the data catalog, identifying where they live, and working and bringing those into your data model from this flat structure. It is extremely cost effective with a very expedient time to value. You're moving data into a data store. There isn't really any modeling taking place, so you can get up and running very quickly. And of course, there are some performance advantages to this technique over some older systems as well. So, with this in mind, kind of like to think, well, how could we draw on some of these strengths? It's important to consider, though, that there are some disadvantages to this technique. If you don't do it correctly, you can end up with very highly regulated environment rather, from a data governance standpoint, or bad data conversely, or it's undefined, or you have quality issues because the data is not validated on ingest. And of course, you do have some potential issues with privacy concerns and how permissions can be allocated across the data lake. So if you take some of those positives there, we start back again with this data lake. Well, essentially, what is the data lake? As Brett noted earlier, to an extent, it's a persistent staging area. So we have full fidelity of all of our source systems. And if we consider then, perhaps what if we added in some master data management components that allow to replicate the same sort of navigable structure. And I think you guys can see where we're going with this here. You're recreating the core components of a data vault, with the caveat that performance is a function of your architecture and your underlying technologies, not necessarily your data modeling techniques. And Data Vault is a modeling technique. So working with that, let's step back and think again about this example of how we might, as data scientists, leverage this data environment for analysis and modeling purposes. So you have the advantages of having this full fidelity of your data in a very navigable, structured environment. You can already see within the raw data vault how common business keys from different source systems are integrated into the same table without loss of history, and really just a more convenient structure to work with, as opposed to having these labyrinth of queries as you're gathering the data and moving more from that 80% data munging, wrangling time for breakdown for a data scientist, and lowering that to focus really where your comparative advantage exists. It's important to note, though, that, as you move towards the right in development, you still have that availability of refined data for the BI developer. And as you move to the left, you still have the raw source system data for your machine learning engineers and data scientists. With all these common features to the data vault, you also have, to the data lake rather, you also have the added benefits that come with implementation of the data vault methodology inside of a RDBMS system, right? So you have the access control and data validation that takes place in the ingest, right? There's defined column structures and data types to those columns. So if there's a bad load, you're going to know about it. And also, probably an important piece that's often understated within the data lake itself. Yes, it's a fantastic central repository, but you lose that integration component that takes place, like we see here inside of the raw data vault. So, with those elements in mind, we're able to really just deliver in that iterative fashion for our clients. So, right.
All right, so it looks like we won as far as we delivered business value in a timely manner and our clients happy. And how we do it? It was all about time to value. It was all about a solution that is tailored to the client needs. With these things, there's no one size fits all. And we did it in an incremental fashion. We failed early and we learned and we got to a holistic, scalable solution. Not only that, in this specific example, we have an architecture that supports not only the, well, for all analytics, as opposed to having something that's broken up and more segmented. So, David, you asked how it went the second time. I think pretty well. Let's go ahead and open up for questions.
So we got a good question here, Brett. When is Data Vault not a good fit?
Yeah, yeah, I'm a hammer for everything's a nail, but that's not the reality of things. So Data Vault wouldn't be appropriate in a situation where you only have one source, or if you don't really care about history, if you're not really interested in if you're a situation where you're not highly regulated, and those other two examples are true. There's also, it's a, not niche, but it's easier to find a traditional data warehouse architect, developer, than it is to find someone who knows Data Vault. So there is that. But all in all, it's a decent solution, not just for analytical environments. It's also used for other types of systems beyond just analytics. So you have to look and see what the client needs, their acceptance to things like data quality, time to value. So I hate to say it, but it really all depends.
Absolutely. And I might echo there, right, to your point that a more traditional ETL developer may not be as familiar with these structures or comfortable. At the same time, coming from a data science background and working on some of these engagements in a data engineering capacity, I can certainly appreciate the repeatable nature of the patterns that allow individuals that may not have the data architecture or data modeling experience to contribute to a warehouse development, leveraging strict coding ability and capacity to recognize very simple patterns. So. Right, does architecture lend itself to a specific or different tech stack or data movement ETL tools?
No, and so it really is tech stack agnostic. You could even do a Data Vault on a file-based system. So it's obviously the tools of choice differ as far as if you're not doing a whole lot of ETL, do you really need a sophisticated ETL tool? If you're more interested in things like execution orchestration and just EL. So I think it definitely factors into the decision making as far as what tools you choose, but it's definitely, I would say it's tool agnostic.
Absolutely. Here's a great question. How would you determine what is a hard business rule versus a soft business rule?
Yeah. So I touched on the concept of a soft business rule earlier. And so in Data Vault, there's hard business rules and soft business rules. Soft business rules are those transformations that we push to the right. We really want those to be business driven with business intent. Hard business rules are applied. These are transformations that are applied typically between the stage layer and the raw Data Vault. And so impact makers, what we've come to is we only apply hard business rules on data such that it is necessary to be able to match on business keys. And so thinking through examples like a banking example, if you have a account number that in some systems, one source system is padded with zeros, it's a 12-digit number. In another system, it is, there's no padding of zeros. A hard business rule would be something where you would apply padding to be able to match those two business keys, to be able to put them into the hub. Another example would be of a hard business rule would be a social security number, where in one system you might have dashes, and another system you wouldn't. And so what you want to do is be able to, you would manipulate that data to be able to accommodate matching. So typically we also like to also keep another attribute that is the source as well. So you really don't want to lose, the key is you don't want to lose any data on the Weather Vault data vault, because it gets back to you want to be able to recreate the source. You want to be able to know what happened to the data.
Yeah, additional question related to project management methodology. In particular, asking about, does this particular solution lend itself to an agile project management process? And yeah, absolutely would be the simple answer to that. As we noted, Data Vault is uniquely advantaged because you can not only employ a agile project methodology to the management of the project, the sourcing of business requirements, but also to the coding and development itself. Because of that, kind of extensible additive nature of the architecture, you're able to parallelize the process across multiple teams, or across within the same team across multiple developers. And as changes occur or arise as a result of changes in business requirements, feedback from the business, et cetera, the code refactoring is far less substantial. I won't say non-existent, but certainly far less substantial than you'll see in more traditional data warehousing techniques.
A huge thank you to Brett and David for presenting, and thank you to all of our attendees for joining. And I hope everybody has a great weekend.
All right, thank you all.